All right, 9.2 example 2 wants us to kind of compare these two functions. And the best place to start is the graph of the two functions. So f of x, or they put kind of f1 of x, which is here. I'm going to color code these beneath. And then f2 of x, they show in blue there. I'm going to write them underneath using the forms that they actually give us. So this is the graph of x squared minus 2x over 4 minus 2x. I'll put just kind of f of x in there in red. And then over here on blue would be our graph of f of x is equal to x squared plus 2x over 4 minus 2x. Now, immediately, the technique that I talked about in example 2 hasn't been done. These two functions are not in their factored form. So I'm going to do that first. So my red function, I could factor an x out of the numerator, which leaves me with, which yields x times x minus 2. And I could factor, this is going to look a little weird, but I'm going to take a negative 2 out of the denominator, which is going to leave me with x minus 2. And that was certainly intentional to try to get that x minus 2 to show up in both. For the blue f of x, and really they should use different letters, I can still take an x out of the numerator. I'm left with x times x plus 2. I cannot manipulate this to get x plus 2 on the bottom, so I'm not going to do that. Oh, wow, no, let's make it look the same. I'm going to take negative 2 out still, and I'm left with x minus 2. Now, the key difference between these two functions, and there is certainly some similarities, and let's do that first. I think similarities are the easiest to find. So similarly, they're both rational functions. So I'm going to put that they're both rational. They actually have an x-intercept in common. They both contain the x-intercept 0, 0. And the reason that I know that is the factor x is present in only the numerator in both of those functions. So we see a pretty common kind of theme there, right? That they both have that x-intercept. There are some differences though. My blue f of x also has the x-intercept, and this is really important. There's another factor for the blue graph that's only in the numerator, and that's the x plus 2. Well, what makes x plus 2 0 is x equals negative 2, so that's where the x-intercept occurs for that. My red function doesn't have another x-intercept, but it does have a point of discontinuity, and I'm going to put at the location where x is equal to 2. But what's the actual point? And that's going to be something that a lot of students overlook when they're writing something in the homework or for marks or whatever that is. When we ask for a point of discontinuity, it's just that. It's a point. It's not just the x value. It's not just the y value. It's that full order pair. So what I'm going to do is I'm going to write g of x because I think it's important that they're not the same thing. But g of x, if I cancel that factor, I'm left with x over negative 2, which means if I looked at the function g, which looks the same, when I put g of 2 in there, I get that g of 2 is equal to negative 1. So my point of discontinuity is actually at 2, negative 1. All right. Other similarities, and maybe I should have done similarities first, is neither of them have a vertical asymptote. Now, a lot of students struggle with that. I'm going to scroll up here, but when you look at that blue function, it looks like it has a vertical. Oh, you know what? I made a big mistake there. Sorry. I don't think I'm going to restart the video, but I got caught up in looking at this red function. Does the blue graph have a vertical asymptote? We need to check, is there a factor that is only in the denominator? And there is, right? That x minus 2 is only in the denominator, so my blue graph does have a vertical asymptote at x is equal to positive 2. Sorry about that. Mistakes happen. It's important to roll with them, I suppose. And I think that's about it for how we could compare these functions. And I think one of the easiest, or maybe the best way of approaching this question is to graph them and then try to look at what they have in common and what's a little bit different. And I'm just going to kind of walk through some of those, similarities. They're both rational functions. I mean, there's nothing really I can show on there. They both have this x-intercept at 0, 0. The difference is certainly the point of discontinuity here. And then really importantly, we have a vertical asymptote at x equals 2, and I have another x-intercept at negative 2, 0. All right, some pretty big differences between the two. The blue graph has something else called a slant asymptote, but we're not going to do that in Math 32. Don't worry about that. The bottom line, and the biggest thing that we need to push again and again and again, I'm just going to pull it up again because I think it is so important to focus, is that idea of based on the factors, how can we determine what's an x-intercept, what's a point of discontinuity, and what's a vertical asymptote? That is the big, big push in this 9.2, that we can analyze these rational functions in a very, very general way, which is important. It's different than transformation, but it still has a lot of value.